Hello and good evening, and I finish up the car prefab with everything that we talked about getting done on it. So basically this was an empty game object that I went and I dragged the city police car, just one of my models I have, and I dragged it into the, just like this, create empty, reset the empty, name it something fancy, and then drag the police car inside of it and basically start dragging in all these other aspects, and then that's how you create that root object. So the root object, it has a box collider on it, and you can see that. Very simple collision checking. You can tweak it and adjust its size to fit something that you like. We have a rigid body on it. We have the car control script right there, and then we have a velocity limiter script, which basically caps the car from going at an infinite speed. Right now, with these settings, the car will go about 90 miles per hour. Inside of the hierarchy for the car prefab, we have a folder called wheel colliders, and if we look at them, these are all the wheel colliders that match each corresponding wheel. Okay? They control all the nice wheel physics and everything going on. We have the wheel slip audio, which is an audio source, and it has a skid sound effect. When the wheels slip and it skids over the pavement, it makes a skidding sound. We also have an engine sound, and we're using the mid. We have a lower bass and a higher pitched engine sound, so a couple of options. This plays the audio for the engine revving. This is the police car mesh. Okay, no big deal on that. One of the important things when you bring in any of your own 3D models for cars, which you probably will, you want to make sure in your 3D package or whatever, when you export out your cars, the wheels are separate meshes, okay? Not combined together. That their pivots are centered around their center, and that the vehicle is facing down the Z. See how the little blue axis is pointing down? All down the Z, okay? Any car will work. Every one of these art wheels, if I, let's make sure we're on PC input, and I'm gonna drive around a little, and you'll see our wheels are turning cool, and of course you see we're doing some pretty awesome drifting, and the front wheels are turning as well, okay, and they're also turning around their own axis. And what that is this wheel alignment JS script right here. It's applied to every one of the art wheels. So when you bring in your own 3D model, make sure to put wheel alignment JS on each wheel, and then drag in the corresponding wheel collider for that wheel. i.e., for example, the left front art wheel has a matching collider left front wheel. Okay, so on that script, we drag the left front wheel collider in. Basically, the wheel colliders turn the art wheels for steering and for acceleration. So make sure you do that. So there's the police car mesh. All of its art wheels have the wheel alignment script, so they will rotate. This whole system will work without rotating the wheels if you don't apply it, but you'll notice when the wheels aren't turning that you need to apply this script. Camera target is just kind of positioned in the middle of the car, and it's what the main camera will follow. So if we hit play, you'll see the target for the car smooth follow is this camera target. And the way that works is this smooth follow script is looking for an object that has a tag called camera target. So anything that you want that camera follow script to follow, tag it camera target, even if it's just your car or whatever, Okay, so the main camera will find that. It also finds the parent rigid body, which is the car, and it uses its calculations to kind of swivel the camera around cool. And it finds the player car rigid body by looking for a tag player. Okay, so that's what the camera is looking for in the two important tags. The car shadow is just a blob shadow projector that's parented in, and it is not casting the shadow on the car, because it is ignoring the layer player. So just make sure your objects that you want the blob shadow projector to ignore, when we pull this up, just make sure to set the mesh and all that you want it to ignore on the proper player layer, okay, or create one if you don't have it. It'll ignore all the stuff on that. And then we have brake light objects, which are pretty neat. It's just an empty game object that's disabled, and they're the brake lights that come on when we back up or try to slow the car down. And these are customizable for any model you drag in here. They're just quads in Unity with the texture on them. So as you can see, they can be hand placed, hand scaled, scaled animation. If you have a different kind of car with the brake lights way out here for both, go ahead and scale them and move them and size them for that specific car. Okay, the script just deactivates and enables this root object, not the actual brake lights. So feel free to change those and do whatever you want with them. Okay, and then I just have a directional light in the scene. It's not casting shadows. And then you asked for NGUI, so we do have some NGUI objects. I'll bring this over and we'll look at it. So I just put a NGUI UI label up here to show those drift points racking up the mile per hours, which was built into the car, so I showed it anyway. And then just a button for debugging. Click it, it sets button inputs down here. Click it, it sets accelerometer, tilt steering, okay? And then gas, brake down here, left turn, right turn, and of course the P is for parking brake or the E brake, and that causes the drift. So we'll look at the script on the car and then we'll be done here. Box collider and rigid body. We'll take a look at car control real quick. As you can see, it says require component, so if you forget to put the box collider or rigid body on it, it will apply those two items and bitch if they're not there. The script is very nicely commented for everything. It'll actually show you all the areas that are NGUI mobile option. These are NGUI things, so if you're not doing the NGUI build, you can straight up kind of comment out all the NGUI stuff. Okay? But it's pretty neat. Here we are, setting a control to accelerometer, setting to control to button. We're choosing between tilt or button control. I've commented out some things, like find control objects is commented out. We're not running it because I don't know what your objects are named, but if they were named brake button, gas button, turn left, these things, the script would automatically at runtime, when you hit play down here, it would fill in all those variables. And the other one we have that's commented out is set platform. This will automatically select PC input if on PC and NGUI input if you're on iOS or Android. It's also commented out set platform is here, but we're not actually setting PC control input or mobile input to true or false with it, but it's checking for the Windows player, which is if you make a Windows executable build, this is the Unity editor, and this is a web player. And then of course the other option for mobile is it Android, is it iPhone? Okay, and when it sets these booleans, this basically, like PC control input being true up here, would hide all of your NGUI buttons and all of that and be full keyboard control. Whereas down here, mobile control input, it would be no keyboard control and all mobile inputs. And you'll see that switch down here. I switched it off. So if it's mobile control input and we bring it up, here we'll set button. See, we have a couple options. We can go button, we can go tilt. The scene just reloads for that. And then of course, if we turn off mobile and go PC, we'll take a look. And we start our drift, and it's really nice. We can control it through a turn and just keep racking up those drift points, but as soon as the drift stops, the points stop accruing. Okay. You can drift and get some pretty big bonuses on that. I'm going to leave it up to the developer, if you want to save those bonus points and then load them for a leaderboard, but that, saving data is a whole nother enchilada on top of what it is we've done. And there's the brake lights working. Okay, we can actually drift and slide in reverse too, which is pretty cool. And so here's the things in the script. This is where you plug that wheel slip audio in for the wheels squealing, the engine. You plug in all your wheel colliders here. Low speed steer angle here is basically at a lower speed going slower, the wheels will still steer sharp, 15 degrees or so. But as your speed gets into the high speed, the steer angle on the front wheels, basically when you turn the steering wheel, they won't turn as sharp. It's as if at a higher speed you lost grip, you know. The drifting slip rear factor is actually taking these rear and front wheel colliders, and it's saying instead of the default value, use this value for the sideways friction, like the slippage. So you can even like knock these down 45, 55, something like that to make the car drift even more. The wheels lose even more traction. And of course this is slip factor for the rear, slip factor for the front. Is drifting is just a Boolean switch that lets us know the car is in a drift, and it allows the points to count up while is drifting is true, and while it's not true, you don't get any bonus points. You would also set that to false if like you're doing a raycast over, I don't know how your game is, but if your player leaves the road surface in a drift and goes onto the grass, you want to kill their drifting points multiplier, just say is drifting false. Can drift is a mobile switch when you're using Ninja UI stuff here. Okay, which I do have the NGUI. Let's just look at a couple. Gas button. See, it's just a typical UI button. Nothing special on that. And for the turning too. They're just standard NGUI buttons. The labels, the UI labels for the mile per hour and the drift points. So going back. So can drift is the switch. When you hit this e-brake, can drift becomes true, and that means because the e-brake is depressed down, you know, you've clicked it once, it turns red like this. Let me see. Oh, let's go to button input. Reload the scene. Something's up. Let's see here. Oh, PC control input. Duh, it's not going to do anything. So always remember to manually switch that since we're not doing the platform checking. And so when that's turned on and the car is going over a certain minimum speed, so can drift becomes true, and the car could drift. Turned off, can't drift. Very easy. So drift points, that's just storing the amount of drift points you've got for drift. And these are all the gears. Engine torque, pretty straightforward. You can adjust the mass of the rigid body's center of mass down and wide to make the car more stable, what I did. These are all the NGUI buttons plugged in. These are just debug boxes to let you know you're pressing gas, brake, left, and turn. These are the switches for mobile or PC. In PC, it'll use the keyboard like we showed and hide all the buttons. And then in mobile, it will display all the buttons, and then you can click right here, button input or tilt input, and get a choice between tilt steering with the accelerometer or button punching. Okay, input control type is it's set by the script. When you click these buttons, input control type 1 is buttons, 2 is tilt. The brake light group is that group right here that we're turning on and off to deactivate and show brakes. Mile per hour display, drift point label. This is the sensitivity of the accelerometer. You can play with this number. Of course, higher will make the accelerometer way more sensitive on the device, and the car will steer quicker. Okay, and lower will make it kind of even out a little more, less sensitive. Smoothing will smooth the accelerometer values out, so they're not rough and crazy jerky numbers. They're actually nice and smooth. Get axis H is horizontal, and that's just a readout for debugging. You could hide that later, showing when the accelerometer is being tilted with the device, and use Unity Remote to test that. And you can see this go from a 0 to 1 or 0 to -1, and that's for steering left and right. Motor input touch, 1 is full gas, 0 is no gas, and that's used when you're in accelerometer mode for gas and brake. Steering sensitivity is used in accelerometer mode too, and it kind of enhances this sensitivity of the device. You can also adjust the sensitivity on the actual car's wheels, and they'll turn sharper, wider. So, And then the dead zone is if they're kind of holding the device within this 0.03 range either way. The car won't start turning until they tilt it just out of that dead zone. So if you want the accelerometer to respond like to the slightest tilt, then lower this down or something. But I found 3 was pretty much a good sweet spot. So at this point, I'm going to let you look at the build running on the lowest end Samsung Galaxy Tab 3. So it obviously supports lower end devices.